Welcome to Chapter 7 with the ITV program, and we're going to be looking at solving systems of equations with three different methods through Chapter 7. The first method we're going to be looking at is a graphing type of solution where we're going to see the point at which two lines cross each other, if they cross each other. That'll be one type of solution. The second type of solution is going to be obtained through the method of substitution. And then the third type is going to be method of addition, which is also known as elimination. This first video is dedicated to the idea of looking at how these systems can be solved graphically. And we're going to go ahead and just do a quick introduction of this by just seeing if certain points work in the system of equations or not. So they're saying here, determine whether each ordered pair is a solution for the system of linear equations. So they have the ordered pair 3, 4 and the ordered pair 1, 6. So typically for these, we're going to have, so one of these points may work in both, but both of these points can't work in both. Because if these are two lines that are being graphed, that means they're going to cross at one place, which we'll have a chance to preview in a little bit. But what we're going to do for this is in each column here, we're going to look at each of these equations, putting these values in. So I'm going to in this first column to the left here, I'm going to put an x plus y equals 7, and then 3x plus 2y equals 15. In this next column here, we're going to have x plus y equals 7, and then it'll be 3x plus 2y equals 15. So the first point we're going to consider is the point 3, 4. So for this first point, we're going to consider 3, 4 here. That means x is 3 and y is 4. So if we put 3 here and 4 here, well, 3 plus 4 is 7, or 7 equals 7. Well, that seems to work. We now want to check to see, when we put 3 and 4 in here, if we get this equal to 15. So this is going to be 3 times 3 plus 2 times 4. This gives us 9 plus 8. And we see that 9 plus 8 is equal to 17. Well, since 17 is not equal to 15, that is a point on this line. But this is not a point on this one. So there needs to be a point that both lines happen to share. So we would say for A, that's going to be no. For the other question here, let's see if our other two values work. So the other two values we're going to be looking at are going to be 1 and 6. So for point B, this is going to be 1 and 6. So we're going to put 1 in for x and 6 in for y. Oops. We see here if we have 1 plus 6 together, that's 7 equals 7. That seems to work. For this other one here, let's go ahead and put 1 and 6 in. So this is going to be 3 times 1 plus 2 times 6. And that'll give me 3 plus 12. And that's going to give me 15 is equal to 15. And since it works in this point and it works in this point, we can say that, yes, this is a solution for this system. And the reason we call it a system is because the combination of two equations, and we have one point that actually works in both. So we're going to go ahead and move down to number 2. And what I'm going to encourage you to do, go ahead and get a little practice. We're asked a similar kind of question. We're given the system here, 2y equals 4x plus 6, and then 2x minus y equals negative 3. And they're asked to check to see if one of these 2 points is a solution for the system. If you want to stop the video and try this for yourself, you can. Otherwise, I'm going to teach you to work through. I'm going to do the similar thing that I did for question 1. And here I'm going to have 2y equals 4x plus 6, and then 2x minus y equals negative 3. Do that over here also. So now for the first point, we have both x and y equal to negative 3. So it'll be 2 times negative 3 equals 4 times negative 3 plus 6. And that's going to be negative 6 equals negative 12 plus 6, or negative 6 equals negative 6. Well, that seems to work for here. We have to make sure it works for here too. That's going to be 2 times negative 3 minus, be careful, negative 3. Well, 2 times negative 3 is negative 6, minus a negative 3, that's going to be plus 3. And negative 6 plus 3 is negative 3. Now, given that this point works, that is a solution. Chance the other one may not be, unless for some reason that these other two lines are just rewritten, but they're the same kind of line. But it seems like, yes, the point -3, -3 is going to be not only a solution, but more than likely the solution. Let's go ahead and try the point 0, -3. So here in this one, watch out. Y is first, that's going to be -3 here. So that's going to be equal to 4 times 0 plus 6. And this will give me a -6 here. That'll give me 0 plus 6. -6 equals 0 plus 6, or just -6 is equal to 6. If that doesn't work, I mean, you could check it in that, but as long as it doesn't work in one, it's not going to be a solution because it has to work in both. So if you wanted to, you can just go ahead and stop right there and just say, no, that's not a solution. Okay, so if you take a look at 1, this point here, if you take a look at 2, this point here, what's special about the point in both of those cases is when we graph these lines, this is going to be the point at which both of these lines will cross each other. So what we're going to do is we're going to look at these equations, and we're going to write both of these equations now. We're going to write them in slope-intercept form, and then use our slopes and y-intercepts to plot them. I'm going to use a little bit of a bigger sheet of graph paper than what's provided when I printed the problems from the homework, and we'll go ahead and take a look at this. All right, so number 3, and I'll provide this piece of graph paper here to help me out with that. It says solve the system of their equations by graphing. So let me move this up so I have this in the way. So what I'm going to do is I'm going to take each of these equations and write these into slope-intercept form. So we have x plus y is equal to 5. We have x minus y equals 3. Now, this first one's not going to be bad because all I have to do is move the x to the other side to get y equals -x plus 5. The other one here, when I move the x over, I'm going to get -y equals -x plus 3, but I need to get rid of that negative there. So if I multiply through by -1, or divide by -1, I will get y equals x minus 3. Okay? So how did I get this result? I multiplied everything through here by a -1. That makes this positive, that makes this positive, and that makes this negative. So in these two lines now, in the equation of y equals -x plus 5, we have a b value of 5 and an m value of -1/1. Here in this equation, we have a b value equal to -3 and then a slope of +1/1. So I'm going to plot each of these two lines, and we're going to observe where these lines cross. The first line I'm going to plot is the first one here, y-intercept of 5. And then remember, the slope is going to tell me to go to the right one, but down one. So the right one, down one. To 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 the right one, down one. You'll notice I'm putting a lot more points than I usually do. I want to make sure I get this right because they have to cross at the precise point. And if you're a little sloppy on your plotting or drawing of the line, you could get a wrong point. So that's going to be one line. The other one is going to be a y-intercept of -3, so I'm going to put that here. But the slope is to the left, to the right one, and up one. To the right one, 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 up one. And you notice it seems like a point these two lines happen to share is right there. So we're going to go ahead and draw the equation of the first line right here. And we're going to go ahead and draw the equation of the second line right here. And if we look at the point at which they intersect, it appears that the point of intersection here tends to be 4, 1. And what we're saying is that the value of x and y needed for this to be a solution is when x is equal to 4 and then y is equal to 1, which we usually write as an ordered pair, which is what they're asking for in this question. So the solution for this problem is going to be 4, 1, because that's where the lines are going to cross each other. Okay. We're going to do a few more of these with you before we call it a lesson. And at least on some of these I have a bigger graph. I will go ahead and let you try. If you want to try 4 on your own, you may want to pause the video before we keep going with this. Otherwise, you may keep watching, and then I'm going to graph this out and see what it looks like. I do recommend trying this on your own, though. Okay, if you're just coming back, what's real nice about this problem is we have both equations written in slope-intercept form. So when we're looking at y equals negative x minus 6 and y equals 6x plus 1, we can see where these, like for example, I know that the b is equal to negative 6, and I know that the slope is equal to negative 1 over 1. Here, my b is equal to 1, and then my value of m is equal to 6 over 1. I'm writing the slope with a 1 underneath it so I can tell how much you go to the right and how much you go up or down. So for the first line, I'm going to start at negative 6, and then I'm going to go to the right one and down 1, to the right one and down 1, to the right one and down 1. Well, let's take a look at this line. Let's say I plot some points from here. I have a y-intercept of 1, and then I have a slope of 6, which means I go to the right one, then up 6. Now this goes up so quickly, I can't get any more points on here. So if I'm going to look for a solution to this system, I need to do some plotting backwards. So it helps to start like with a point, and this time I'm going to go to the left and up 1, left and up 1, left and up 1, keep going, left and up 1, left and up 1, left and up 1, okay? I think that'll be enough to get a point of intersection. But in here I go to the left one and down 6. Let me go to the left one, down 6. That looks like the point there, okay? If you go to the left one, down 6, we're going to be something like this. So that point it shares seems to be this one right here. We want to try to capture that when we draw the two lines. We want to make sure that we do all this work very accurately. So doing this work with graph paper is very important. So it seems like the coordinate of this point where they intersect is going to be negative 1 and then negative 5. So it appears that negative 1, negative 5 is going to be the solution for this system that we're looking for. Just want to make sure that all that work is visible. Okay, excellent. In number 6, the graph paper provided for the question here is very nice, bigger than what I even have. So if you want to pause the video to try this on your own, just bear in mind you're going to need to do a little manipulation with this one. You can stop the video, otherwise I'm going to continue on to show how this one's done. Okay, so what I'm going to do here is I'm going to just bring some blank paper here, and I'm going to show how I need to manipulate the first one a little bit. So we're going to have 2x minus y equals 4. I need to write this in slope-intercept form in order to plot this. So I'm just going to move the x over, giving me negative y equals negative 2x plus 4. And then, if I multiply through everything through by negative 1, because I want to just change the sign to positive y, that'll give me y equals 2x minus 4. And now I've got this written in slope-intercept form. So what I'm going to do is I'm going to introduce this here, y equals 2x minus 4, where for this line, the y-intercept, the value of b is equal to negative 4, and then the value of m is equal to 2 over 1. The other line we're given is y equals 2. And remember, when we are missing one of the two variables, the two questions we ask is, what axis is across and where does it cross? So let's go ahead and just get this drawn first. So we know it crosses the y-axis at 2. So I'm going to go ahead and put a horizontal line through the y-axis. And again, keeping in mind that you want to graph this really as precisely as possible. Now let's take a look at the next line here. So we have y equals 2x minus 4. So I'm going to start by plotting on the y-axis at negative 4. And then I'm going to go to the right one and up 2. So to the right one up 2, to the right one up 2, to the right one up 2. So looks like our point. The right one up 2, to the right one up 2. And we could draw a line through that, making sure to be really precise about that point. We have to draw a line through it so we can get it. And it appears that the solution to this is going to be 3, 2. So this is going to be 3, 2 for this system. Now, if you want to, you could run a check of this just to make sure that this works out. So if you want to test it, you can put this in. So let's say, for example, for the first equation, we have 2x minus y equals 4. If x is equal to 3 and y is equal to 2, does that work? So we have 2 times 3 minus 2. Now does that equal 4? So that's going to be 6 minus 2 equals 4. 4 equals 4. That seems to work. And then if we have y equals 2, well, We only need the y value from the point, and 2 equals 2. Golly gee, that works. So that looks like it appears to be our solution to this system. Okay, I think we'll have a couple other questions in this section before we call this a day and wrap this up. So let's take a look at the next problem here. The graph paper on this is pretty big, maybe just because the point of intersection is somewhere kind of far out there. Again, if you want to stop the video and try this problem on your own, please feel free to do so. Just as a little reminder, you're probably going to want to move some things around. That'll help quite a bit, actually. Okay, so let's see how you adjusted these things here. So we're going to have 2x plus y is equal to 6. And then we're going to have 4x equals negative 2y plus 8. So what I would do is I would move this x to the other side. That's going to be y equals negative 2x plus 6. Over here, I'm going to move the x to the opposite side. I'm going to move the y to the opposite side. So this isn't written in, so where this one was written in standard form, this one's just kind of a cluster of bleh. There's nothing, no real organization to this. If we want to write this in slope-intercept form, this needs to be moved, this needs to be moved, switch the signs. 2y equals negative 4x plus 8. And then finally, if I want to get y by itself, I need to divide everything by 2. Divide by 2, divide by 2, where y is going to equal negative 2x plus 4. So this one's a little bit of an interesting one. Let's just see what happens in this case here. So here we have y equals negative 2x plus 6 with a y-intercept of 6 and a slope of negative 2 or 1. Here in this problem, we're going to have the b value of plus 4 with a slope of negative 2 over 1. And you may have recognized that, hey, we seem to have the same slope here. Let's see what happens when we have this instance. So I'm going to bring this down just a little bit and try to graph this. So if we have a y-intercept of 6, and I'm going to bring the other graph paper in here. I realize this is big and I know where they're trying to go. Well, the other piece of graph paper is going to do the job in a way that's a lot easier to understand. Because that graph is just too big for the purpose of videos. So, sure I've got everything in there? Excellent. Okay, so I want to plot 6 here, and I want to go to the right one, but down 2 to plot my line. Right one down 2, 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 and so on. The other line, if I plot it, this is going to be negative 2x plus 4. So I'm going to start at 4, then you go to the right one down 2, 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 and if you're waiting for these things to touch, they're never going to. Because since these lines have the same slope, now they're real close to each other. They're real close to each other. But since they have the same slope, these lines are what we call parallel lines. They're basically streets that go in the same direction, so they're never going to cross. So in this kind of situation, what we say is that there is no solution in this particular question because the lines are parallel to each other. Okay? So we get problems like this sometimes. So you expect to see questions like this in your homework, as we saw in this example for question 6. So let's go and take a look at number 7 now, and let's examine the solution here. So again, we're probably going to want to rewrite this equation a little bit, okay, to get both of these in slope-intercept form. So I'm going to take advantage of the space I have below here to do that before I cover it up with a graph. So the first equation I want to rewrite in this system is negative 6x minus y equals negative 8. And then the other one's going to be 1/2 y equals 4 minus 3x. One thing about this here, everything is negative here. I mean, if you want to just move the x over first and then multiply by negative 1, you can do that. I'm just going to go ahead and multiply everything by negative 1 first. So I'm going to get 6x plus y equals 8. That way, now if I just move the x over to the other side, that's going to be y equals negative 6x plus 8, and I'm done. You would get this result if you had moved over the x first and then multiplied by negative 1, but I just like to get rid of all the negatives at first because it seems a little cumbersome sometimes. In this other equation, we have 1/2 y, but we don't want 1/2 y. We want just y. So I'm going to multiply everything by 2. 2 times 1/2 is just 1. 2 times 4, that's going to be 8. And then 2 times -3x will be -6x. Now, if you're looking at this, you may say there's something a little off. And the only thing that's off is it's not written with the slope first, the y-intercept second. It's written with the y-intercept first and then the slope. So you can just kind of rearrange things to make this -6x plus 8. So if you happen to look at this, you see here, in both cases, we have identical equations. Not only do they have the same slope, but they have the same y-intercept, which means the two lines are going to plot on each other. And that's going to be a situation that when the lines plot on each other, they're going to be infinite or many solutions. Infinitely many solutions. Not infinite or many, infinitely many. And that's going to wrap up our video on section 7.1.